Deep learning, an exciting intersection of machine learning and artificial intelligence, is causing a major disruption in society and industry. It's one of the most valuable skills you can learn in this century. I'm thrilled you're here, and I hope you'll share my excitement as we dive into this powerful and pervasive field. Deep learning methods are changing the world. ATS applications are everywhere, from optimizing car engines to determining what you see on social media. This technology is not just powerful. It's fun. Here, we'll explore the core concepts. Deep learning. A specialized area within machine learning and artificial intelligence, driving significant advancements and changes in various fields. Machine learning, a broader field that encompasses deep learning, focusing on algorithms that allow computers to learn from data. Artificial intelligence, the overarching field encompassing both machine learning and deep learning, aiming to create intelligent systems. By the end of this journey, you'll have gained highly valuable and impactful skills applicable across diverse domains. This section explores 3 compelling reasons to learn deep learning. Its power to automate intelligence. Its potential impact on skilled labor, including job displacement, and its inherent fun and creative aspects. Deep learning represents the latest chapter in humanity's ongoing quest to build tools for understanding and controlling our environment. Unlike previous innovations, deep learning focuses on automating intelligence itself. This mental innovation builds upon earlier advances in AI and machine learning, incrementally automating increasingly complex cognitive tasks. Deep learning has already achieved remarkable success in diverse fields like computer vision, speech recognition, and machine translation, primarily using a single brain-inspired algorithm, neural networks. The versatility of this approach is striking, and recent advancements suggest that deep learning might even offer a window into the workings of our own minds. While often overhyped, the potential for deep learning to automate skilled labor is a significant implication that deserves serious consideration. Even with current capabilities, deep learning can profoundly impact skilled labor globally. Professions like call center operators, taxi drivers, and low-level business analysts are particularly vulnerable, as deep learning offers a low-cost alternative in these areas. This potential for job displacement underscores the importance of adapting to the changing landscape and considering a transition into the growing deep learning industry. Beyond its practical applications and economic implications, learning deep learning is a fun and inspiring endeavor. It offers a unique intersection between human and machine intelligence, providing a fascinating opportunity to explore what it means to think, reason, and create. Simulating intelligence and creativity in machines can be both enlightening and inspiring. Imagine teaching a machine to paint like Monet. It's mind-bogglingly cool. This creative aspect of deep learning adds another layer of excitement and intellectual reward to the learning process. Incremental automation of intelligence, the process by which deep learning gradually automates cognitive tasks, building upon previous successes in AI and machine learning. Mental innovation, a type of innovation exemplified by deep learning that focuses on automating intellectual or cognitive processes as opposed to purely mechanical ones. Neural networks, the brain-inspired algorithm largely used by deep learning to achieve its accomplishments across various fields. Job displacement, the phenomenon where automation, particularly through deep learning, replaces human jobs, especially in skilled labor sectors. Will this be difficult to learn? This section addresses the often asked question about the difficulty of learning deep learning. The focus here is on the fun payoff, seeing something you've built actually learning. You'll experience this very early on by Chapter 3, and these payoffs are structured throughout the book to keep you engaged and motivated. A core concept in this book is the fun payoff. This is the rewarding experience of witnessing something you've created actually learn and adapt. This early and tangible result helps address concerns about the perceived difficulty of deep learning, providing immediate gratification and motivation to continue learning. This book is designed to provide a smooth learning curve with frequent fun payoffs. Instead of a long slog through abstract theory before any practical application, you'll quickly build a working neural network, giving you a sense of accomplishment and fueling your desire to learn more. The book follows a structured approach to maximize engagement and learning. Build early on. In Chapter 3, you'll create your first neural network. This is your first fun payoff. Memorise. After each chapter introducing new concepts, you'll memorize a small, manageable code segment. Read. You'll then move on to the next chapter, building upon your existing knowledge. Experience. After reading, you'll put your new knowledge into practice, experiencing another learning neural network, another fun payoff. This cycle of building, memorizing, reading, and experiencing ensures consistent practical application and reinforces learning through tangible results. The immediate gratification of seeing your creations learn is a powerful motivator, making the learning process more enjoyable and less daunting. This book offers a unique approach to learning deep learning, focusing on accessibility, foundational understanding, and practical application. It aims to empower you with the knowledge and skills to effectively utilize deep learning tools and contribute to the field. Many deep learning resources assume a high level of mathematical proficiency, often requiring a college-level background in mathematics. This book breaks down that barrier. You don't need a degree in a math field. A solid grasp of high school math is sufficient. Instead of getting bogged down in rigorous mathematical proofs, we prioritize understanding how deep learning works. This approach makes the field accessible to a wider audience, enabling anyone with the motivation to learn a dive into deep learning. Key takeaway. No advanced math prerequisite. Rusty high school math is sufficient. Focus on practical understanding. How over theoretical mathematical depth aims to make deep learning accessible to a broader audience. This book doesn't just teach you how to use specific deep learning frameworks like Torch or TensorFlow. Think of it like this. A NASCAR driver doesn't just learn how to drive a particular car model. They learn the fundamental principles of driving itself. Similarly, this book focuses on teaching the underlying science under the hood of deep learning. By understanding the core principles, you'll be better equipped to understand and effectively use any deep learning framework, not just the flavor of the month. Key takeaways: distinction between framework usage and deep learning science. Priorities: foundational knowledge of deep learning principles. Prepare readers to understand and effectively use any deep learning framework. We believe that complex mathematical concepts can be made intuitive and accessible. This book translates every mathematical formula and concept into relatable real-world analogies. We break down complex math into digestible parts, making it easier to grasp without oversimplifying. We adhere to the principle of making things as simple as possible, but not simpler. Key takeaway. Math concepts are explained through intuitive real-world analogies. Avoid taking formulas at face value. Breaking them into understandable parts enhances comprehension by connecting abstract math to concrete examples. We believe that true understanding comes from doing. This book adopts a project-based learning approach. Instead of purely theoretical lessons, you'll be building things from the get-go. Explanations are provided as you progress through the projects, ensuring you gain practical experience and understand the context of the tools you're using. This hands-on approach prevents the accumulation of theoretical knowledge without practical application, empowering you to solve real-world problems and understand when and why to use specific tools. Key takeaway. Learning by doing. Immediate application of tools to build projects. Avoid theoretical knowledge without practical relevance. Develop problem-solving skills and understanding of tool applicability. Empowers readers for careers in research and industry. This section outlines what you'll need to follow along with this book and begin your deep learning journey. We'll cover the necessary software and libraries. The assumed mathematical background and a strong recommendation for maximizing your learning experience. This book has a few prerequisites to ensure you have a smooth learning experience. These are divided into software/libraries and mathematical background. You'll need the following software and Python libraries. Jupyter Notebook. Jupyter Notebook provides an interactive coding environment that allows you to stop network training and inspect components. This is incredibly useful for gaining a deep understanding of what's happening under the hood. You can find installation instructions at http://jupyter.org. Installing the Anaconda framework. http://docs.continuum.io/anaconda/install is recommended as it simplifies the Jupyter Notebook installation process. NumberPy Python library. This book uses NumberPy, a powerful matrix library, throughout its examples. Using a single matrix library allows us to build everything from scratch, enabling a deeper understanding of how each component works. This soup-to-nuts approach helps you truly grasp the underlying mechanics rather than just relying on high-level framework calls. Installation instructions are available at http://nupi.org. Like Jupyter Notebook, NumberPy is easily installed using the Anaconda framework. http://docs. The continuum.ios/anaconda/install Python version. The examples in this book are written in Python 2.7, but they have been tested and are compatible with Python 3. High school mathematics. A basic understanding of high school algebra is sufficient. The book assumes you might be a bit rusty with your math and explains any other necessary concepts as they are introduced. While not strictly a prerequisite, the following recommendation is crucial for maximizing your learning and success with deep learning. While listed as a recommendation, finding a personal problem or project to tackle is highly encouraged. Consider it a crucial need rather than optional. This is for several important reasons. Intrinsic motivation and engagement. Working on a problem that genuinely interests you provides intrinsic motivation, a powerful driver for continuous learning. It fuels your desire to read the next chapter, build the next prototype, and push your understanding further. Rapid expertise. Deep learning is a new and rapidly evolving field. By focusing your learning on a specific project, you can quickly become a leading expert in that niche area. Sustained learning. A personal project acts as a dependency for your learning. It gives you a reason to keep going, to overcome challenges and to deepen your understanding. Real-world example. The author's personal experience exemplifies this. A project using Twitter data to predict the stock market led to a research grant within 18 months. The key catalyst for success is to identify a fascinating problem that involves using one dataset to predict another. This type of project provides a concrete goal and a tangible application of your deep learning skills. This section clarifies the Python knowledge you'll need to get the most out of this book. We'll explain why Python is the chosen language for our examples and point you to a helpful resource if you need to brush up on your Python skills. Python is our language of choice for all code examples because of its intuitive syntax, widespread use, and the community's dedication to simplicity. More specifically, we'll be using Python 2.7, although the examples have been tested for compatibility with Python 3 as well. There are several key reasons for this choice. Intuitive language. Python is remarkably easy to read and understand, even for beginners. Wide adoption and readability. It's one of the most commonly used programming languages, known for its clear and concise syntax. Community emphasis on simplicity. The Python community actively promotes clean and understandable code, making it an ideal learning environment. While Python is the primary language for the book, we also provide downloadable source code with examples translated into several other programming languages. You can find these resources online at www.manning.com/books/grokking-deep-learning https://github.com/imtrash/grokking-deep-learning You should have a basic understanding of Python to comfortably follow along with the examples to help you assess your current Python knowledge. We recommend checking out the Python course on Code Academy www.codeacademy.com/learn/python. Here's a simple self-assessment. Scan the table of contents of the Code Academy Python course. If you're familiar and comfortable with most of the terms and concepts listed, you're likely well prepared to continue with this book. If you encounter unfamiliar terms, we strongly recommend completing the Code Academy course before proceeding. This will ensure you have the foundational Python skills necessary to understand the code examples and concepts presented. This approach will allow you to gauge your Python proficiency and identify any potential knowledge gaps before diving into the core deep learning material. Our goal is to ensure you have a smooth and productive learning experience. This summary confirms your readiness to proceed to Chapter 2 and provides a glimpse into what awaits you. We'll reiterate the essential prerequisites and set the stage for the next phase of your learning journey. By now, you should have a working Jupyter Notebook installation and a comfortable grasp of basic Python. These are the key foundations we've built in the previous sections where you need to get started, and Python knowledge requirements and resources and are crucial for moving forward. Chapter 2 marks the final chapter primarily dedicated to conceptual discussions and establishing a shared vocabulary. Unlike later chapters, it won't involve hands-on coding projects. Think of it as the essential groundwork before we dive into building and experimenting. Chapter 2 aims to equip you with the high-level vocabulary and foundational concepts you will need throughout the rest of the book. This includes an overview of the key fields within intelligence systems. Artificial intelligence AI will explore the broad definition and scope of AI. Machine learning. ML, you'll learn how ML fits within the larger context of AI. Deep learning. DL will define DL and its relationship to both ML and AI. This high-level understanding will provide the necessary context for the more practical project-based learning that follows.